That's no different with the tangent. Let's jot this down. This says y equals inverse tangent of x, which means that the tangent of y equals x. Now x, if you remember the graphs for these tangent functions, the x value can be anything. In other words, the tangent of an angle can be anything. Those are those graphs that just kept going up forever. However, the y values are going to go from negative pi over 2 to pi over 2. So all of these answers for inverse tangent will go from negative pi over 2 to 2. Pause if you need to. So let's look at this. Tangent was a little bit different. We said that the sine of an angle is equal to the y value. The cosine of an angle is equal to the x value. Well, the tangent, recall, if we have the tangent of theta, is a ratio of y over x. So we have to take into account both of those values. So if we're looking for the inverse tangent of 0, we're trying to find out where is the ratio of y over x equal to 0. Well, if we want a ratio to be 0, that means the top value must be 0. So where the y value is 0 would be over here at the coordinate 1, 0. So that would be the coordinate 0 over, or the y value, I'm sorry, that would be the tangent being 0 over 1. And that happens where the angle there is actually 0. So y in this particular case would be 0 because the tangent of 0 is 0. Now the tangents get a little bit tricky here. With this one, we've got the inverse tangent of negative 1. That means we want the y over the x ratio to be negative 1. Well, the only way for a fraction to be negative 1, or to be 1 in general, is if the y and the x value are the same. If you notice, we have a y value actually right here, where the x value is radical 2 over 2, and the y value is negative radical 2 over 2. If you put this y value over this x value, that actually does give you a ratio of negative 1. Let me just write that out. Negative radical 2 over 2, that's the y value. The x value is radical 2 over 2. And that ratio is equal to negative 1. The angle that is there is 7 pi over 4. Okay, however, we had a restriction back here that the angle cannot, or has to be, between negative pi over 2 and pi over 2. Well, that 7 pi over 4 is not between negative pi over 2 and pi over 2. What we can say, however, is if we rotate in this direction, pi over 4 units, we can actually call that negative pi over 4. So your answer there would be negative pi over 4. Last, if you have this ratio is supposed to be radical 3, well, if you take a look, we've actually got a couple of coordinates that involve the radical 3. This one right here is 1/2 radical 3 over 2, and this one down here is radical 3 over 2, 1/2. Now, we're looking for the ratio so that if we put the y value over the x value, or this y value over this x value, so that that ratio ends up being just radical 3. Well, let's take a look at this one. If you put radical 3 over 2 over 1/2, these 2's cancel out, and that gives you radical 3. So this coordinate that I circled is our answer. Well, the angle that's there is pi over 3. So my answer is pi over 3. I understand some of you are probably a little overwhelmed right now again, but hey, be patient here. Once you get to studying these, it will sink in. I can come close to almost guaranteeing it. Okay, so now let's talk about the reciprocal inverses, and just jot these down real quick here. If you've got the inverse tangent of x, that means that the cotangent of y is equal to x. X is between negative infinity and infinity, and y is between 0 and pi. Again, just jot all that information down right now. I'll get a little bit more specific as far as y, especially why the angles are between 0 and pi. Okay, pause if you need to. For the inverse cosecant, meaning still the same, y equals the inverse cosecant of x means that the cosecant of y equals x, where the absolute value of x is greater than 1, and this y value is still between negative pi over 2 and pi over 2. Now that was, in one little added piece of information here, the y value cannot equal 0. And the cosecant matches up with the sine. Remember, the sine was also negative pi over 2 to pi over 2. And then with the secant, remember with the cosine, the y value went from 0 to pi. Well, that is also true here as far as matching up with cosine. So with the inverse secant, the y value is again going to be between 0 and pi. And now, y will not be able to equal pi over 2. So let's get some examples of these inverse functions, and then we will call it a day. So for the inverse cotangent, we'll recall that the cotangent is a reciprocal of tangent. If the tangent is y over x, then the cotangent must be, you guessed it, x over y. If we want that ratio to be 1, then we're looking for a ratio to be just that. We want the ratio of x over y to be equal to 1. Well, that can only happen right here at the coordinate radical 2 over 2, radical 2 over 2, because if the x and the y values are exactly the same, that would give us a ratio of 1. The angle at that coordinate is pi over 4. So our answer is pi over 4. Where we want the secant to be 2, well, now let's think about this. If the secant of an angle is 2, that means that the cosine must be the reciprocal of that, right? Thanks for the backup. So we really could write this out as the inverse cosine of 1/2. Makes it a little bit easier to think about. Because we're trying to figure out where is, cosine is x, so where is the x value? 1/2. And the x value is 1/2 at this coordinate. And that coordinate is pi over 3. Likewise here, where the cosecant is 2 over radical 3, well, the cosecant is the inverse of sine, or is the reciprocal of sine. So let's find where the sine of an angle is radical 3 over 2. That actually is the same as this coordinate right here. We're looking for the y value to be radical 3 over 2. And that happens again at pi over 3. Hey, you'll have an assignment to work on here. What you may need to do is even go back and kind of clarify by looking at this video. Again, it should be there for you to watch, and then try that assignment. Don't forget that on Facebook I will be there in case you need anything, and I certainly hope to be back tomorrow. Alrighty, see you then.